morning. Yeah, so I'm here today. Want to introduce you to some work we have been doing in the standard bodies and also started to code on this, which is around privacy enhanced conferencing, shortly PERC. So let's start with like a very simple, typical conferencing scenario, like peer-to-peer in WebRTC. Super simplified here with only 3 participants. But essentially, like Alice and Bob establish a peer connection to each other. All the transport is encrypted. You know whom you're connected to. But obviously, with 3 people, you already have like 2 peer connections open to the 2 other participants. And when we scale this to like more people, like 10 people or whatever, you end up with like 10 or more, like n peer connections. And from a client's perspective, from Firefox perspective, this actually gets us a little bit into a problem, because like every new participant basically means a new peer connection, means I need to encrypt all the traffic, I need to resend the same video frame from my camera like n times. So all in all, the mesh conferencing works well for like a low number of participants, depending on your hardware, like 4 to 8, something around that. Different providers have different experience and different limitations. But the pro of this solution is basically that everything is encrypted end to end, and you really know whom you're connected to, which endpoint you can verify that basically. The other alternative is basically a server-based conferencing solution. As you can see, you only have like 1 peer connection to a server. The bad sides from a client perspective of like having to run multiple peer connections is gone. But the problem now is that you have an encrypted transport to the server, and you have no idea where's the other media coming from, who is connected to that server. You basically you trust that server, but you don't know what the server is doing with the media, because your encryption is going from your client to the server. And the server decrypts the media, has full access to the media, can modify it, can drop it, can do whatever it wants with it. And so on the other hand, also like on the receiving end, you have no idea where the media is coming from, which the server is actually sending to you. So yeah, the pros of that solution is, like, as I said, like only 1 single peer connection. It scales a lot better, because obviously, because you only have 1 peer connection, you can connect like n clients, and you as the only client, you won't suffer from more clients, except like more video streams going through the same peer connection. And then another benefit is that you only have to worry about net traversal or firewall traversal for 1 peer connection, whereas like in the mesh scenario, basically every new peer connection you run into the same trouble of like, oh, will we be able to actually establish a connection? But as I said, the cons of the server-based solution is basically, okay, can I trust the server? And then also from a operations perspective, like where do I run the server? Do I have like my own on-premise server, or do I run it in the cloud? If it's in the cloud, can I trust the cloud? And so on and so on. Another point, just for completeness here, is like obviously the one server is a single point of failure. If the server goes down, your whole conference is gone. Which in the mesh scenario, if like 1 client disappears, the rest of the conference would still keep on going. But that's not a problem we're going to solve here today. So now getting to PERC. PERC tries to, I would say, combine the best of the 2 worlds. So it's a server-based solution. So we get the benefit of only having to open like 1 peer connection and don't have to connect to n clients. So it scales better. But basically what we do at PERC is we remove the ability from the server to have full access to the media. So the media goes encrypted end to end to all the participants. Another benefit is that also the identity part is also moved out of the actual relaying server. A very simplified high-level architecture diagram would look something like this. So you have the 3 clients, Alice, Bob, and Charlie. they establish their peer connection, which is like the light gray connection to the media distributor. That's in the previous picture, that was the server. But the media distributor no longer takes care of any key management. So the whole management of like who has which keys, who has access to which keys, got moved out into a separate entity. And as you see, that's like on purpose in a different box. In reality, the key management can live with the media distributor on the same box. If it's like a trusted environment, there's no reason to not do it. But if it's like in a scenario where you want to run your media distributor in, like, let's say in a cloud, and you don't necessarily trust the cloud provider fully, you can run your key management function somewhere else, on premise, on your own laptop, several options. So what does the PERC client do compared to what it does in a normal conference? It basically encrypts the media twice. It encrypts it once with its own public key, basically, and that public key is known to all the other clients in your conference, and then it encrypts it a second time with the key of the media distributor. And so but the second part is that the DTLS connection, which is part of the peer connection normally, is not established to the media distributor, but the media distributor just forwards it to the key management function. So essentially you have almost like two connections logically. One is all your media is sent to the media distributor, and he handles that, but all your DTLS traffic is actually sent to the key management function. So the media distributor, on the other hand, when he receives an RTP packet, he decrypts it with his own client, his own key, sorry. But what he then holds is still an encrypted RTP packet. He has access to certain parameters like the SSRC and the sequence number, but he has not access to the actual RTP payload. And so what he does is he decrypts the incoming packet, and then before he forwards it to all the other participants in the conference, he encrypts it with the actual keys per client, for all the other connections to all the other clients. So he has basically the load of still encrypting it per client, but that's no different to the previous simple server-based solution, because there the server also holds n peer connections and needs to encrypt n times for each media packet. And then the little important difference is that whenever the media distributor receives DTLS, he simply forwards it to the key management function. And the key management function basically just sits there, waits for incoming DTLS connections. These are basically connections coming from the actual clients. And then he establishes the full DTLS connection and has that way like an encrypted connection to the clients. And then he assigns the media distributor the actual keys to be used between the media distributor and the PERC client. So that's like he generates these keys and tells the MDD like, here's your key to talk to Alice. Please use this key to talk to Bob. Please use this key to talk to Charlie. And yeah, so that's basically the role of the key management function. So here's the probably a little bit overloaded and a little bit more complex diagram. I took out Charlie to make it a little bit easier. So hopefully it's visible. Yeah, so like the light and dark gray between like Alice and the media distributor and Bob and the media distributor is basically the outer encryption with the shared key between the media distributor and Alice, for example. But then the actual RTP in the blue and green arrows, that's still encrypted a second time with like Alice or Bob's keys. So the media distributor just passes the blue and green traffic through. He cannot decrypt it. And the red and yellow arrows basically are the DTLS connections between Alice and the key management function and Bob and the key management function. So as I said, the media distributor just passes that through. For reliability purpose and also for authentication purposes, the key management function in the current spec has a TLS connection with the media distributor. But that's not like really for encryption purposes, mostly to make sure that the two can authenticate and so on. We talked about different options, and currently it's a TLS connection, which probably will work fine. So all in all, I think this gets you This is deployment. So what is the advantage over like a regular service here? Is you could for the media distributor, you could, for example, you could envision that there's like a cloud service which says like, hey, we're running like media distributors, and you don't have to trust us, but you can like rent capacity from us if you need it. If you want to spin up a conference, sure, here, you pay us whatever, like per participant, per minute, whatever the business model is, right? Or you could go and like, maybe there's going to be another platform service which says like, sure, like spin up your own media distributor on Amazon, on EC2 or something like this, and shut it down once you're done with your conference, right? Or you could also go the full enterprise solution and run your full MDD all the time on premise if you want to. And then with the key management function, there are like basically two vague or two ideas where you could run this. One would be, I guess, the typical enterprise scenario is that there's like a permanent running key management function on premise, fully under control from IT, fully secured. And it basically ensures that everyone who participates in conferences in the company is properly identified and all the keys can be trusted. Or, and that's obviously the scenario which Mozilla cares more about, is like for more like an ad hoc conference scenario, you could actually spin up a key management function inside your browser. And you invite like two other participants. You rent capacity on one of these like media distributors with shared capacity, but you don't trust that provider with like identity encryption. So you spin up your own key management function, and as much as you trust your own laptop, you trust that the key management function is secure, and that way the key management function can ensure that all the parties are connected properly, everything is encrypted, and your media distributor, your media relay has no access to any of the media going through the media distributor. So the reason why why I'm here is like we started working on this last summer with a prototype of the key management function. Actually, to what we talked about yesterday, the different approaches from Mozilla versus Google. So we tried to implement the spec at the time, and it turned out that the spec wasn't working as it was written. So we had to revise the spec like twice during the summer while we did the development. But we fixed the draft, so there's like a new draft version now. This is the TLS connection between the key management function and the MDD. That's the result of that work. And so we implemented the key management function. But the remaining work is, so the idea is that Mozilla will have a PERC client in Firefox, and we'll also want to have like a key management function in Firefox. What we still need to do is we need to work on the double encryption. As I said earlier, every PERC client needs to encrypt each payload, each RTP packet twice. And then another part is that basically so to allow the key management function to send keys to the clients, there's like an extension to DTLS which we still need to implement. The timeline is still a little unknown. We have started with the key management function now, and we're hoping to have like a prototype maybe like early next year. But obviously we have a dependency because Mozilla has no interest in actually implementing a media distributor. So if anyone is interested in writing one and start inter-op testing, please let us know. That would be very interesting to us. That's it. Any questions?
Maybe you spoke about this earlier, But I'm wondering, does this protocol have some sort of authentication built in so that Bob knows that Alice is Alice and Alice knows that Bob is Bob?
There's not a specific extension to it. It's basically the same as you would use for WebRTC. There's like an identity extension, and you would do that with the key management function. So because you have the DTLS connection to the key management function, you can then basically, over that connection, you can verify identities end-to-end between these two. And then the key management function would basically be the relay of like, you would verify that you're talking to the right key management function, and the key management function, and on the other hand, ensures that it's talking to the right clients. So I think there's, at least currently, there's no way to do an end-to-end identity verification, if that's what you mean.
Well, that's tricky, right? So there should be some sort of permanent public key that the key management function knows about, I guess.
Sure, that will be one way of doing it. Yeah, yeah. I mean, the details of the identity management has not been worked out, so it's still work in progress. But yeah, there are different alternatives you could take to that to ensure that. Yeah.
Other questions?
So I'm still not sure I understand. I can see that you're reducing the number of connections, obviously, from the peer-to-peer model. But the MDD is not really a switch. It's still sending all the traffic from all the clients to each client, right?
Yep.
And it still has to decrypt each individual client. So I'm trying to understand where the costs. I thought one of the things you were trying to solve with this was scalability at the endpoints.
No, from the endpoints perspective, we get the benefit of having only one peer connection towards the server in the old scenario, or the MDD in the PERC scenario. From that perspective, we get the benefit of scaling through the server. Like if we add like 10 participants, the server needs to take care of that. The client is not burdened with that, and the client sends his like video frame, for example, out once to the server, to the MDD, and the MDD needs to multiply it by 10 times and send it out through all the other clients, right?
Right.
But the key difference is that in the normal current scenario with like an MCU or an SFU, that server, once it has taken your RTP packet out of the peer connection, has full access to your media and can basically like do whatever it wants with it and like modify it however it likes before it sends it on to all the other participants. And the other participants have no way to verify that whether that server modified it or not. And in the PERC scenario, basically, we take that privilege away from that server.
I understand, but you're still, I mean, one of the things an MCU would do possibly is tile the video into a single frame and into a single stream, but you still have multiple streams going to every client, right? Yeah,
this would be like a typical scenario you would combine this with for like a large scale solution would be, for example, like, I mean, the actual media distributor would work like a selective forwarding unit, and you might want to combine it with simulcast, for example.
Okay.
And so like the clients, the PERC clients on the receiving end will basically receive like N video streams, and they will have to do the composition and all of that locally on the client.
That's what I was missing. Okay, thanks.
Yeah, I guess maybe just to clarify, it's really more for a SFU scenario versus a MCU. Is that fair?
It's well, I mean, like if you assume that an MCU is typically something which can do composition and stuff like that, and this is clearly more like an SFU scenario, because I mean, on purpose, the MDD has no access to media, so it cannot merge video pictures or do anything to the audio, right? So like the client basically receives all the basically the raw traffic from all the other clients and needs to take care of the composition locally.
Yeah, it's not for scenarios where the media server is going to decode the video.
No, and obviously the server no longer can do like things like recording, for example, right? I mean, on purpose that wouldn't work, right?
Yeah.
Yeah, I guess, you know, from a security perspective, why can't, even if you don't trust the server, why can't the server admit bogus recording nodes? Right? I mean, you can have a recording node that can get the keys like anybody else, right? Well, bogus
yeah. Oh,
yeah.
you mean like? Oh, yeah. You mean you could add like you could instruct your key management function to allow another node being
Yeah.
the recording node.
Yes, you can still record.
Yeah, but not as part of the MDD, basically.
Right, yeah.
Yeah.
So how would this work in a simulcast scenario? So I guess what you want to accomplish there is to have the receiver being able to select which stream is being forwarded or which quality or resolution is being forwarded. Would that work?
Or the MDD can also do the selecting of the video stream, right? Theoretically, because it has like at least access to the different SSRCs. So it has like limited access to the actual RTP header. So it can do the selection of like, do I want to forward the high resolution or the low resolution to the client? Theoretically, you could implement that in the MDD.
Right.
Or you forward everything to the client and then the client would have to pick.
But if it's all in one stream and it is SVC, then you wouldn't be able to do that in the MDD.
No, if your different resolutions are in one video stream, then the MDD can no longer help with that. Then that has to happen on the client. Yeah.
Are there any other questions?
So the end client has to decrypt everything that, if you have a 10-person conference call, the end client has to decrypt all 10 of those conversations. Is that correct?
Yes.
So you really have to have a beefy, if you have a big conference, you have to have a very beefy client on all the clients. You can't use a small handheld or whatever it's going to be.
Yeah, I mean, it's like it's essentially, I guess from the crypto perspective, the same as the full mesh or similar to the full mesh scenario, but with the difference that you don't have to handle as many peer connections. You don't have to send out your own video end times, but still you have to decrypt. You have to decrypt the every packet which comes in once from the MDD and then per each client, basically. Yeah.
Anything else? All right, thank you, Nils. So that actually concludes the WebRTC and CPaaS track. Thank you for